Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hope you all are doing really great. So students, in this video we are going to solve the question from the chapter Wave Optics, important for the JEE exam. Okay, so see, the question is a thin transparent film with a refractive index 1.4 is held on circular ring of radius 1.8 centimeter. The fluid in film evaporates such that transmission through the film, the keyword is transmission through the film at wavelength 560 nm goes to a minimum every 12 seconds, assuming that the film is flat on its two sides. The rate of evaporation is how much here? Okay, so in this question we have to use the concept of interference that is happening on the films and all, like a soap film is there, or above the water any oil and all is there, na? That kind of concept we have to apply. So remember that here first I will note down the data here, na? Then I will tell you the basic concept. So what data is given here? If we talk about here the refractive index of the film, it is given here 1.4. After that, ring radius, what is given here? You can see very well, the radius R is given here 1.8 centimeter, that means 1.8 into 10 to the power minus 2 meter. After that, the wavelength is also given here. The wavelength is given by lambda equal to 560 nanometer, that means 560 into 10 to the power minus 9 meter. And minimum, remember that here in a what we can tell, in a interference and all that, if we talk about the maximum means constructive interference is happening, and minimum means what is happening, destructive interference is happening, like a YDSC. You can see in a YDSC what we have learned: whenever constructive interference, bright fringes; whenever destructive interference, dark fringes, just like that. Okay, so minimum to minimum, that means from one minimum to the second minimum, how much time interval is there? 12 seconds, because they are telling, see, minimum every 12 seconds happening, goes to a minimum every 12 seconds. That means minimum to minimum, how much time it is taking here? It is given here the 12 seconds. Okay, so this data is given here, and what they are asking here, they are asking the rate of evaporation. Okay, so what will happen that here, if we talk about here, let's take here, I have taken here one transparent film of thickness T, is it? So what will happen that here, let's take some incident light is coming here and striking on the surface here. So what will happen? Some part will be reflected and some part will be refracted, or we can tell transmitted. Again, after reaching here, some part will be reflected and some part will be transmitted. Again, after reaching here, some part will be, what we can tell with respect to this part transmitted, and what happened that here, this part reflected. Again, what will happen? It will refraction or transmission will happen, is it? So we can tell very well here, if we talk about here this first surface here, on this first surface, what is happening that here, both these rays, whether this ray or this ray, what is happening that here, they are coming out from the which one? First surface. So this is called here the reflected rays, or we can tell here this is the reflected system. This system here, the students say, this is the reflected system, we will tell here. Now we have got here the two rays. So here what will happen that here, let's take, if this angle is R. So if we talk about here the reflected system, which one here, students? Reflected system. So for the reflected system, what will happen that here, in this situation, if we talk about here the constructive interference or maximum, so in this situation what will happen that here, the value 2 mu t cos r should be equal to n minus half lambda. Okay, and if we talk about here the destructive interference, that means minima, so in this situation 2 mu t cos r will be how much here? N lambda. This is applicable for the which system? Reflected system. Okay, but in our question, what they are telling here, you can see the keyword they are telling here, the transmission, is it? So for the transmission system, transmission is happening where? Which ray? This ray and this ray, you can see both are transmission system. So this is called here the transmission system or transmitted rays. Transmission system. Okay, transmission system. Here what is happening? The interference is happening between these two rays are here. So in this situation, what will happen that here, remember that here, for a transmission system, okay, system, that is important, transmission system. So here, remember that here, for the constructive interference, this will be 2 mu t cos r is equal to n lambda. Formula will be reverse. Okay, and second one, what is there, for the destructive interference, that means minimum, the formula will be 2 mu t cos r is equal to n minus half lambda. Is it? This is our basic. Remember the formula. Any formula can be used anywhere depending upon the question. But now if we talk about the question, they are talking about here transmission. That means we have to use this one. Okay. After that, what is happening, that they are talking about the minimum. That means we have to use which formula? We have to use destructive interference formula. The formula is 2 mu t cos r is equal to how much? N minus half lambda. Na? So this is our formula. Now what will happen, that when these rays are very close to the normal, so what will happen, I will be small and r will be also very small. This is called paraxial rays. So when r is very small, what will happen, r we can tell approximately 0 and cos 0 how much here, 1. So what will happen, that here in this, instead of cos r, I will write here 1, and this formula I am going to use here. Now can you see very well? Okay. So what we are going to write? So students, we have seen in this situation, we have to use the formula of water transmitted system minimum. Minimum is water destructive interference. Okay. So we have got very well for a minimum, that means for a destructive interference. Is it? What formula is there? We have got the formula 2 mu t r, as I have told you, r is 0 degree paraxial rays. So 2 mu t is equal to water n minus half lambda. Is it? Because minimum to minimum is given 12 seconds now. So if we talk about here, we'll get the value of the thickness. So T equal to, it will come here water n minus half, and this will become here lambda by 2 mu here. Is it? Now students, after that, if we talk about here the values now, so let's take, I'm going to put the values now. Let's take values, I'm putting here n equal to 1, n equal to 2, 3, 4, like this I can put. But now what we have to get? We have to get a minimum to minimum. That means I'm going to put first 1 and then 2. Okay. So what this will come here, the students here. So first one, when I will put here the value of n equal to 1. So for n equal to 1, now see here please, for n equal to 1, what is coming? It will come here t equal to, just put n equal to 1. So 1 minus half, half. So this will become here lambda by 4 mu. Okay, lambda by 4 mu it will come here. This is t is lambda by 4 mu. Is it? After that, if I put here for n equal to 2, is it? So for n equal to 2, what will come here? Put n equal to 2. So 2 minus half, it will become here 3 by 2 into lambda by 2 mu. So in this situation, it will come here what? 3 lambda by 4 mu. Is it? Now you tell me which value is more? The 3 lambda by 4 mu value is more compared to lambda by 4 mu. Even here you can see one ring is there, na? And this dotted is the thin film is there. So initially, what is the thickness? T1. So when some part will evaporate, the thickness will become T2. So you can see very well the thickness is what? Decreasing. So what is this? This is the initial thickness T1, 3 lambda by 4 mu, and this is the final thickness is what? T2, lambda by 4 mu, because minimum to minimum 12 seconds. Okay. After that, what will happen that here? The students, you know very well here, they are asking rate of evaporation. Okay, so if I talk about here the rate of evaporation, okay, rate of evaporation. So here we have to get here the volume by time. Even you can see here, here also you can see if they are asking meter cube by second. Is it? So rate of evaporation means volume by time. So what is the volume? Let's take here, this ring is having cross-sectional area A, and this thickness how much here? You can see very well here, delta T. So how much material, how much volume will evaporate? That means volume. Na? Amount means volume. So A into delta T. What this will come here? We can write here A into delta T by, we can tell here the time. Okay, A into delta T by time, because here T represents the thickness. What is the area? Area means we can write here, see, pi r square into delta T by time here. Is it? So this is the time here, okay, time, and into delta T. Delta T, what it will come here? Kindly see, it will come here T1 minus T2. So 3 lambda by 4 mu by lambda by 4 mu, what this will come here? 2 lambda by 4 mu. Now this difference, this will come here 2 lambda by 4 mu. Is it? So now after that here, we are just going to put here the values. So this is pi. And r square, how much here? Kindly see the r value is given here. See 1.8 into 10 to the power minus 2. So we can write here c square. Na? So 1.8 into 1.8 into 10 to the power minus 4. Okay. And you can see very well, it will cancel out here. 2 2s are 4. Is it? So lambda value what is given? I think so 560 nm. 560 nm. See here 560 nm. That means we can write 56 into 10 to the power minus 8. Or okay, I will write as it is, no problem. 560 into 10 to the power minus 9. Okay, by time what is given? Even I remember 12 seconds into 2, and what is the value of the mu? The mu value is given here, students, how much here? 1.4. Okay, so I will get here the 1.4. After that, what I am going to do, I am just going to collect the power. Here you can see they are giving power minus 13 and pi. So pi and minus 13 I will collect together. This pi and this power minus 4 and minus 9 I have collected together. So what this will come here? Pi into 10 to the power minus 13 meter cube per second. But after that, what other things are left that we have to write here? Okay, so see what is left here. See 1.8 into, see here 1.8 into 560, and here down what will come here? See 12 into 2 into 1.4. Okay, so students, you have to just simplify this, very easily. You will get here the 54 into, as it is, pi into 10 to the power minus 13 meter cube per second. Na meter, this unit is there, na unit is there, meter cube per second. This answer is coming in meter cube per second. Okay, so what is coming here? The answer is what here? 54 is the answer. Can you see very well? Can you see? Is it? So we'll just go here and let's see here what is the, we have to fill here, 54. Okay. So students, I hope so. This question based upon the thin film is very clear to you. There we have used the concept of transmitted system and destructive interference, because they ask the minimum and we have seen minimum to minimum. Okay, that's why we have got here T1 and T2 from the which condition? Minimum condition. Okay, keep studying, keep going.